All right, and we got problems number 3 and 4 from the Geometry Chapter 8 practice test here. Number 3 is asking us to find the area of the rectangle that has one side that's measuring 17 inches and a diagonal measuring 30 inches. So I have the rectangle drawn here. It's not drawn on the practice test, so you have to draw that out. And I'm going to label the sides that were given here. So we know that one side is 17 inches and the diagonal, which is what's drawn right here, is 30 inches. So I'm going to label those two things. 17 inches for one side, 30 inches for the diagonal, labeling those appropriately. And this is a rectangle, so we know that this angle right here is a 90-degree angle, resulting in this figure, or half the rectangle, is a right triangle. And we want to find the area of the rectangle, and the area of a rectangle is the base times the height. Well, we don't have the base, so we need to find the base by using the Pythagorean theorem. In this case, we have the value of the hypotenuse, or the value of c, it's 30. So when I plug this into the Pythagorean theorem, I'm going to do 17 squared plus b squared equals 30 squared. And I leave the b blank because b is the missing side of one of the legs that we're looking for. So I plug it into the formula as what you see on the screen. Now I'm going to evaluate the squares. 17 squared is 289. B squared remains b squared because I don't know what b is. And 30 squared is 900. To solve for b, I'm going to subtract 289 from both sides of the equation, meaning that b squared is 611. That is not the value of the leg here. This side is not 611 long because that's what b squared is. So we have to take the square root of 611, which is 24.72. So that this leg right here, or this length, is 24.72. As a result, this top part is also 24.72. So I can label that appropriately, and now I'm in a position to be able to find the area of the rectangle, because the area of the rectangle is the base times the height. So I'm going to take 24.72 and multiply that by 17 to find that the area of this rectangle is 420.24. Number 4, we have a circle, and we're told that the sector of a circle, and the sector is the slice here, kind of like if you're cutting up a pizza or a pie or taking a portion. This is the center of the circle, and this has an area, this thing, of 18.75 pi. That's the area of just the slice, not of the whole circle, just of the slice. And we're looking for the radius of the circle and the arc length of the sector. And the arc length of the sector is this distance right here, and the radius is from the center out to point on the circle. The first thing I'm going to do here is to take a look at how much of the circle I'm working with. And this is 30 degrees right here, and all the way around the circle is 360 degrees. So I'm working with 30 out of 360 degrees of the circle. Therefore, I'm working with 1/12 of the circle. Where does 1/12 come from? That's 30 over 360 reduced to lowest terms. So this right here, this sector, this slice, is 1/12 of the circle, which means that 12 of these things fit inside this circle. So I need to keep that in mind, that I'm working with 1/12 of the circle. And I know the area of that 1/12. The area of that 1/12 is 18.75 pi. So if I want to find the area of the whole circle, I'm going to do 18.75 pi times 12. Because there are 12 of these 18.75 pi's that make up the whole circle. And I get 225 pi. Notice I leave the pi as pi. The 225 comes from 12 times 18.75, and I leave it as pi just because I don't want to deal with decimals. So 225 pi, this number is very important. This number is the area of the whole circle. And I found that because I knew the area of this piece, and I know that there are 12 of them in the circle, so the area of the whole circle must be 225 pi. I'm not looking for the area of the circle, however. I'm looking for the radius of the circle. But if I have the area, I can find the radius by using the area formula for a circle. Because the area of a circle, in this case 225 pi, is equal to pi r squared. Pi r squared comes from the formula for the area of a circle. So the 225 pi is equal to pi r squared, And if I solve for r here, because I'm looking for the radius, the first thing I'm going to do is divide both sides of this equation by pi to eliminate each of these pi's. So if I divide by pi on both sides, I'm left with 225 equals r squared. Divide this side by pi, it goes away. Divide this side by pi, this pi goes away, leaving us with 225 equals r squared. Now I'm in a position to find r. I don't want to know what r squared is. I want to know what r is, so I'm going to take the square root of both sides and find that 15 is equal to r. Therefore, 15 is the radius. So the radius of this circle is 15. You're also asked to find the arc length. So now we're going to find the arc length of the circle. And once again, we're working with 30 degrees of the 360 of the circle. So once again, we're working with 1/12 of the circle. So we're working with 1/12, or we're looking for 1/12 of the circumference. If I know how far it is all the way around the circle, I can take that and divide it by 12, because 12 of these arc lengths go into the circle from the 30 divided by 360. So I need to find the circumference of the circle and then take that and divide it by 12, because this right here is 1/12 of the circle. So therefore 12 of these must make up the whole circumference of the circle. How do I find the circumference? By needing to know the diameter or the radius. But we know the radius, we just found it. The radius is 15, so the circumference then is going to be 2 times pi times the radius. This right here is how we find the circumference, 2 pi times r. We know what r is, it's 15. So 30 pi, notice once again I'm leaving it in terms of pi, I'm not changing pi to a decimal, I'm leaving it in terms of pi. So 30 pi is the circumference. The distance around the circle is 30 pi. But I'm looking for just this arc length. And I know this arc length is 1/12 of the circle. So if this is the whole circle, the circumference of the whole circle, and I'm looking for 1/12 of the circle, I'm going to take 30 pi and just divide it by 12. And if I just leave it like this is good enough for me. 30 pi divided by 12, that is the length from here to here. I have no idea really how big that is. I kind of have an idea, but it's not very straightforward. But this is the arc length of this sector right here.